Okay, so we're going to pick up from where we left off yesterday with last night's video. Okay, so now we're going to do the evens. So if we take a look at number 2, we see that here we have addition. So we know if we want to combine these two separate log expressions that are on the left-hand side of the equation, we can combine them into one by multiplying the x by the x minus 3. So let's rewrite this as log. Now again, we don't see a base, so if you want to put base 10 to help you out, or if there's no base shown, it means there's a base 10, of x times x minus 3, and then we'll bring down the equals 1. Okay, so now that we have one single log expression on the left-hand side of the equation, we can circle the base and run the race. So when we circle the base and run the race, the 10 becomes the base on the left-hand side of the equation. So that's 10 to the first power. And then I'm just going to bring down the x times x minus 3. Because remember, the word log drops off once we move that base. Okay, so let's solve this equation. So I'm going to distribute x times x is x squared. And then x times negative 3 is negative 3x. And if I subtract 10 from both sides of the equation, I'll have the right-hand side of the equation being equal to 0. So we have x squared minus 3x minus 10. All right, so this one's not so bad. So all we have to do is just factor and solve. All right, so we'll put an x and an x here, and then two numbers that multiply to negative 10 and add to negative 3 would be negative 5 and positive 2. All right, so when we solve, we get x equals 5 and x equals negative 2. Now let's check if we created any 0 or negative logs. I mean, this is just an x right here, so if we take a 5 and plug it in, that's positive. And if we take a 5 and plug it in here, 5 minus 3 is also positive, right? Positive 2. So we're going to keep that one. All right, but this one doesn't look like it's going to work out for us. If we take the negative 2 and put it where the x is, we'll have log of a negative number, and we can't have that, so we're going to cross it off. Also, I mean, it doesn't really matter, but if you had plugged it in here, it would also create a negative log. So, that one doesn't work out for us either. All right, so we're doing the evens. So let's take a look at number 4. So number 4, we again have addition here. So let's make these into one single log term by multiplying what's here and here. So we could rewrite this as log base 8 of x minus 6 times x minus 6, and let's bring down the equals 2. Okay, so now that we have one single log expression on the left-hand side of the equation, we can circle the base and run the race. So the 8 becomes the base on the right-hand side of the equations, and the 2 becomes the exponent. And this word log is dropping off, so we're just going to bring down the x minus 6 times x minus 6. And I mean, from this point, it really just becomes solving an equation, which I know you guys are all great at. Okay, so when we double distribute, we get x squared minus 6x minus 6x plus 36. And then I'll bring down, 8 squared is 64, so let's bring down the 64. And I know we have to combine like terms here, but let's do that, kind of all in one step. We know we also have to get this side of the equation set equal to 0. So we're going to subtract 64 from both sides of the equation. And I'm going to combine my like terms on the left now. So when I combine negative 6x and negative 6x, that gives me negative 12x. And then 36 minus 64 would be negative 28. All right, so factor, and let's finish. Okay, so we have an x and an x, and two numbers that multiply to negative 28 and add to negative 12, negative 14 and positive 2. All right, so this time when we solve, we get x equals 14 and x equals negative 2. So let's see if we create 0 or negative logs anywhere. So if we take the 14 and substitute it back in here, 14 minus 6 is positive 8. And since this is the same thing, you don't have to check it twice. All right, so this one's good. And then here, if we take negative 2 and substitute it in, negative 2 minus 6 is a negative. It's equal to negative 8, so we can't have that one. Okay, so if you flip to the back, we have number 6 and number 8 left to go. So number 6 has subtraction in here, so we know that we can use the quotient rule, right? Subtraction tells us we can make it into one single log term by dividing the two terms. All right, so I'm going to rewrite this as log base 4. And remember, what's to the left of the subtraction sign? Oop, that's supposed to be a 2. Goes in the numerator. And then what's to the right of the subtraction sign goes in the denominator. And I'm going to bring down the equals 1. You know what, let me just make that look a little nicer because that was pretty sloppy. Oh, that's just as sloppy. All right, it's not so easy to write with the stylus. All right, anyway, now that we have one single log expression on the left-hand side of the equation, let's circle our base and run the race. So the 4 becomes the base on the right-hand side of the equation, and the 1 becomes the exponent. And then again, this word log drops off, so I'm just going to take this fraction and just bring it right down. So we'll have x squared plus 3x over x plus 5. Okay, and since we have a fraction on this side of the equation, let's make this side of the equation into a fraction by putting it over 1 and cross-multiplying. So x squared plus 3x times 1 is just x squared plus 3x. And then bring down the equal sign. And then 4 times x plus 5 gives me 4x plus 20. Okay, distribute it to both terms. Okay, so since we have an exponent on our x, we know we need to set one side of the equation equal to 0. So I'm going to subtract the 4x and subtract the 20. And we'll do the same thing to the left-hand side of the equation. So on the right-hand side of the equation, everything cancels. And on the left, we're left with x squared. And if we combine these two terms, we get a negative x. And we'll bring down the minus 20. Okay, so we're going to factor. We're going to come up with two numbers that multiply to negative 20 and add to negative 1. Okay, so multiplying here and adding here. So that's how we got negative 5 and positive 4. Okay, so now, let me just keep the color the same. When we solve this, we get x equals positive 5 and x equals negative 4. All right, so if we plug this back in, let's start with the positive 5. So if we plug in 5 squared plus 3 times 5, well, that's definitely a positive, right? 25 plus 15 is going to be positive 40. So it doesn't matter what positive it is. As long as it's a positive, you can keep it. And if we take 5 and plug it in here, 5 plus 5 is also a positive, okay? Positive 10, so we can keep that. All right, now let's plug in the negative. I'm sorry. Yeah, that should say negative 4. I don't know why I wrote 4. Let me slide the, you know what? I don't want to, let me erase this, actually. Okay, this should say negative 4. Okay, so let's substitute the negative 4 in. So negative 4 squared is positive 16. And 3 times negative 4 is negative 12. And 16 minus 12 is positive 4. So when we plug this in, it creates a positive. Okay, so now let's take the negative 4 and plug it in here. So negative 4 plus 5 is positive 1. So we can circle that as well. Both values create positive logs. All right, and for the very last one, number 8. Now, number 8, I put two rules over here. I put the quotient rule and the power rule. Because, I mean, we only did one example with the power rule, but if you remember, if you have a number in front of the word log, you can raise it up, right, and make it an exponent. So that's exactly what I'm going to do. I'm going to take this 2, and I'm going to make it an exponent on the x. And that's the first thing you want to do. You always, when you're solving an equation, you want to start off with the power rule. So I'm going to rewrite this as log base 4 of x squared, right? Again, I'm taking this and making it an exponent on the x. And then minus, I'm just going to bring everything else down. Log base 4 of 2 equals 1. Okay, now that we've applied the power rule, now we can use the quotient rule. The quotient rule says if we're subtracting 2 log terms, we can make them into one log term using division. Okay, so I'm going to rewrite this as log base 4 of x squared divided by 2. and then I'm going to bring down the equals 1. All right, so just like we've been doing, circle the base, run the race. So we're going to have 4 to the first power on the right-hand side of the equation, and on the left-hand side, the log drops off now that the base is no longer there, and I'm going to bring down the x squared over 2. Okay, and since this side of the equation is a fraction, let's make this into a fraction by putting it over 1 and cross-multiplying. So x squared times 1 is x squared, and then 4 times 2 is 8. Okay, so now, in order to solve, all we have to really do is just take the square root, right? If we take the square root of both sides, we get x equals. Now, the squared tells us we should have 2 answers, so we always remember to put the plus and minus. And radical 8, we're going to have to simplify that. We could break that down, since it's not a perfect square, into radical 4 times radical 2. So that gives us plus and minus 2 radical 2. All right, so, we have to take the positive 2 radical 2 and substitute it back in, and then the negative 2 radical 2 and substitute it back in. Now, since this is an x, if we just plug in positive 2 radical 2, that's a positive log. That works. If we plug in the negative 2 radical 2, that's going to create a negative log. So, unfortunately, that answer we cannot have. So, our final answer is just x equals positive 2 radical 2.